actual measured electrical demand for office spaces, including heating, ventilation, and air conditioning, abbreviated as HVAC, can vary widely depending on a number of factors, including the size and type of building, the climate, and the occupancy patterns. However, a reasonable range for electrical demand in office spaces is between 5 and 10 watts per square foot. To understand this better, firstly, consider that building size significantly influences electrical demand. Larger buildings generally have more extensive HVAC systems, more lighting, and a greater number of occupants and equipment, leading to higher overall energy consumption. Secondly, the type of office building also matters. A high-rise office tower will likely have different energy needs compared to a single-story office complex due to factors like elevator usage, facade design, and the complexity of the HVAC system. Thirdly, climate plays a crucial role. Buildings in hotter climates require more cooling, increasing the demand on HVAC systems. Similarly, buildings in colder climates need more heating. The design and efficiency of the building envelope, including insulation and window glazing, will also influence how much heating or cooling is needed to maintain comfortable indoor temperatures. Fourthly, occupancy patterns have a direct impact on electrical demand. Office buildings with higher occupancy rates during peak hours will naturally consume more energy. The types of activities conducted in the office space also contribute. For example, data centers or research labs within an office building will have significantly higher energy demands than standard office areas. To provide some specific examples, a study by the Lawrence Berkeley National Laboratory found that the average electrical demand for office spaces in the United States was 5.7 watts per square foot. This study likely encompassed a wide range of building types, climates, and occupancy patterns, providing a broad national average. Another study by the New Buildings Institute found that the average electrical demand for office spaces in California was 6.5 watts per square foot. California's climate and building codes, which are often stricter than those in other states, may contribute to this slightly higher average. For an office building with electric heat in the Boston area, an electrical demand of 6 to 7 watts per square foot is reasonable. This falls within the typical range, but it's essential to remember that this is just an average. The actual demand for a specific building may be higher or lower depending on the factors mentioned earlier. If there are concerns about the electrical demand for an office space, there are several steps that can be taken to reduce it. One effective strategy is installing energy-efficient lighting and appliances. Traditional lighting, such as incandescent or fluorescent lights, consumes significantly more energy than LED lighting. Replacing old lighting with LED fixtures can result in substantial energy savings. Similarly, using energy-efficient appliances such as Energy Star certified computers, monitors, and printers can further reduce energy consumption. Another measure is upgrading to a more efficient HVAC system. Older HVAC systems can be less efficient, consuming more energy to provide the same level of heating or cooling. Upgrading to a modern high-efficiency HVAC system can significantly reduce energy consumption and lower operating costs. These systems often incorporate advanced technologies such as variable speed drives and smart controls to optimize performance. Implementing occupancy sensors to turn off lights and equipment when not in use is also effective. Occupancy sensors detect when a space is unoccupied and automatically turn off lights and equipment, preventing energy waste. These sensors can be installed in individual offices, conference rooms, and other areas that are not constantly occupied. Encouraging employees to unplug electronics when not in use is another simple yet effective way to save energy. Many electronic devices continue to draw power even when they are turned off, a phenomenon known as phantom load. Unplugging devices such as phone chargers, laptops, and coffee makers when they are not in use can eliminate this phantom load and reduce energy consumption. To delve deeper into energy efficiency measures, one can explore various strategies. Firstly, conduct an energy audit. An energy audit involves a thorough assessment of a building's energy consumption patterns and identifies areas where energy waste can be reduced. A professional energy auditor can evaluate the building's envelope, HVAC system, lighting, and other equipment to identify opportunities for improvement. Secondly, improve insulation. Proper insulation in walls, roofs, and floors can significantly reduce heat loss in the winter and heat gain in the summer, lowering the demand on HVAC systems. Insulation materials with higher R values provide better thermal resistance. Thirdly, seal air leaks. Air leaks around windows, doors, and other openings can allow conditioned air to escape and outside air to enter, increasing energy consumption. Sealing these leaks with caulk or weather stripping can reduce air infiltration and improve energy efficiency. Fourthly, optimize HVAC controls. Implementing advanced HVAC controls can optimize system performance and reduce energy waste. These controls can adjust temperature settings based on occupancy patterns, weather conditions, and other factors. Fifthly, utilize daylighting. Daylighting involves using natural light to illuminate interior spaces, reducing the need for artificial lighting. Designing office spaces with ample windows and skylights can maximize daylighting benefits. Sixthly, consider renewable energy sources. Installing solar panels or other renewable energy systems can generate electricity on site, reducing reliance on the grid and lowering energy costs. Solar panels can be installed on the roof or integrated into the building's facade. Seventhly, implement a building management system, abbreviated as BMS. A BMS is a centralized control system that monitors and manages various building systems, including HVAC, lighting, and security. A BMS can optimize energy performance, improve occupant comfort, and provide valuable data for energy management. Eighthly, educate occupants. Educating employees about energy conservation practices can encourage them to adopt energy-saving behaviors. Providing information about turning off lights, unplugging electronics, and adjusting thermostat settings can help reduce energy consumption. Ninthly, participate in demand response programs. Demand response programs incentivize building owners to reduce their electricity consumption during peak demand periods. Participating in these programs can help stabilize the grid and lower energy costs. Tenthly, regularly maintain equipment. Regular maintenance of HVAC systems, lighting, and other equipment can ensure that they are operating efficiently. Replacing air filters, cleaning coils, and lubricating moving parts can improve performance and extend equipment lifespan. Another consideration is the impact of plug loads. Plug loads refer to the electricity consumed by electronic devices and equipment that are plugged into electrical outlets. These loads can account for a significant portion of an office building's total energy consumption. To manage plug loads effectively, firstly, implement power management settings. Configuring computers, monitors, and other devices to automatically enter sleep mode when they are not in use can reduce energy consumption. Secondly, use smart power strips. Smart power strips can detect when a device is not in use and automatically cut off power to it, eliminating phantom loads. Thirdly, encourage the use of laptops. Laptops typically consume less energy than desktop computers. Encouraging employees to use laptops can reduce overall energy consumption. Fourthly, provide centralized charging stations. Providing centralized charging stations for phones, tablets, and other devices can reduce the number of individual chargers plugged into outlets, minimizing phantom loads. Fifthly, monitor plug load energy consumption. Using energy monitoring devices can track plug load energy consumption and identify areas where energy waste can be reduced. Understanding the impact of ventilation is also critical. Proper ventilation is essential for maintaining indoor air quality and occupant health. However, excessive ventilation can increase energy consumption. To optimize ventilation, firstly, implement demand control ventilation, abbreviated as DCV. DCV systems adjust ventilation rates based on occupancy levels, reducing energy consumption when spaces are unoccupied. Secondly, use heat recovery ventilation, abbreviated as HRV. HRV systems recover heat from exhaust air and use it to preheat incoming fresh air, reducing the energy required to heat or cool the ventilation air. Thirdly, ensure proper air distribution. Proper air distribution ensures that ventilation air is effectively delivered to all areas of the office space, maximizing its effectiveness. Fourthly, maintain ventilation equipment. Regular maintenance of ventilation equipment can ensure that it is operating efficiently and providing adequate ventilation. Analyzing building orientation and design is important. The orientation and design of an office building can significantly impact its energy performance. Firstly, optimize building orientation. Orienting the building to minimize exposure to direct sunlight can reduce heat gain in the summer and heat loss in the winter. Secondly, use shading devices. Shading devices, such as overhangs, awnings, and window films, can block direct sunlight and reduce heat gain. Thirdly, incorporate natural ventilation. Designing the building to promote natural ventilation can reduce the need for mechanical ventilation. Fourthly, use high-performance windows. High-performance windows with low E-coatings and insulated glazing can reduce heat transfer and improve energy efficiency. By taking these steps, one can reduce the electrical demand for an office space and save money on energy bills. These measures not only benefit the environment, but also contribute to a more sustainable and cost-effective operation for businesses.